I'm going to talk about proof of reputation as a liquid democracy for distributed systems. And the journey that I'm going to talk about is more than 20 years old. It has started at WebMine project, working with Ben Goertzel at this startup, and some ideas that came during this project has eventually led up to creating the Aigents social computing platform that I was running for several years. And the idea of this social computing platform was giving people a chance to figure out the relationships that people are having on social networks and building the models of the social environments, and describing the peers and the partners, and showing people who are the peers and the partners they are talking about to make the stronger and more efficient relationships. And then it ended up with development of what we call proof of reputation concept. And eventually, when I joined with SingularityNet 5 years ago, we have came up with what we call distributed decentralized reputation system and weighted liquid rank algorithm that I will be talking about just in a minute. And eventually we have implemented the SingularityNet reputation system in Python, which was also along the way implemented as a similar reputation system in Java. And then the reputation system for SingularityNet has been explored as being an efficient tool for building reputation system for any marketplaces beyond the SingularityNet. And again, I'll show some results on it at some point during this presentation. Also, the concept of this reputation system has been implemented in SingularityNet Mindplex startup, and then it is being developed and explored for being part of the Hypercycle project. At the same time, I'm working with my students on building the reputation consensus for blockchain, and also for implementing the concept of reputation system for more efficient recommendations. So talking about details on these endeavors, in Aigents social computing platform, we are making it possible for a user of the Aigents component to build up connections with the feeds and contacts and peers and other people that people are connected to through their accounts on Discourse, forums, Slack, Telegram, Reddit, Twitter, social networks. Then also people can link their accounts on blockchains like Ethereum, and the social networks built on top of blockchain like Steemit and Golos. And using the social graph analysis on these blockchains and social networks, we can come up with the reputation scores representing the fairness and reliability and trustability of every node on such a network, where the node in such a network is obviously is either a person or organization or decentralized organization, or it might be even a virtual entity being an agent impersonating particular person or particular service. And during this study, we have found that in order to make a fair assessment of the reputation for a node on the network, we need to come up with something more complex than just counting likes or votes. We need to figure out that every vote or every like on the network has its cost, and the cost of the like is or a vote is can be considered as a reputation of the person who is making the vote. And we concluded that instead of counting the weight of the node on a network based on the what is called proof of work in the proof of work consensus, or based on the amount of stake which is part of the proof of stake consensus, we can weight the value of the node based on the reputation which is owned by the node on the network, and the reputation is based on the reputation ratings given by the other participants on the network, and weight of the other participant is in turn is based on the ratings given to this person. And so we can build what we call liquid rank, weighted liquid rank, because we weight these ranks accordingly to the weights of the people. So one of the applications that we have made with SingularityNet for the marketplaces, we have tried to apply this weighted liquid rank algorithm as a tool for fraud resistance, and we have implemented the proof of concept reputation system in Java and in Python, and made a massive computer simulation trying to see how the large marketplaces where people sell and buy particular goods, and where people are suffering by scam and reputation gaming being implemented by the agents or sellers who are acting on the market dishonestly, saying low quality goods with the reputations of these goods or their own trading accounts being artificially pumped up by the botnets. And we have found that whenever you implement any simple rating system or on a network like 5-star rating system, then inevitably you immediately get most of the audience suffering from the scam, because it's quite easy to abuse such a reputation system, creating botnets where the bots are pumping out the accounts, and in some cases it gets more I would say profitable to sell low quality goods and invest into the bots pumping up your reputation instead of selling high quality goods. And what we have found that if we implement the right reputation system, then we can nicely isolate these low quality good sellers along with the bots who are promoting these low quality good sellers. These are red points, and we can rather identify the fair vendors or fair sellers who are not using reputation gaming, who are earning their reputation based on the organic ratings, and we can also discriminate the honest raters against dishonest raters. So we can identify both honest vendors and suppliers and dishonest vendors and suppliers. So honest ones are blue and dishonest ones are red, and we can make marketplaces safer and more fair places for the business. Another thing that we have tried is we tried to use this unified liquid rank reputation competition to be applied for different social media platforms. So this weighted liquid rank algorithm that we have came up with SingularityNet now use it in the Aigents platform across multiple social networks and blockchains. We have applications to deal with ratings and reputation computation on Vkontakte social network, Twitter, Reddit, Slack, Telegram, Discord, and 3 blockchains like Ethereum, Steemit, and Golos. Moreover, one of my students has run the work to see how the reputation system based on this weighted liquid rank can be used to improve the quality of the content recommendation. So when you are doing content recommendation based on the social media and social graphs on social media, you might have a problem with the same reputation gaming because of the particular content may be promoted by the dishonest voters or likers who are promoting your fake or abusing content in by some sort of the botnet. So we have shown that if we implement the weighted liquid rank, we can decrease the importance of the non-organic or reputation gaming based ratings, and we can benefit or increase the value of the ratings made by honest organic raters. And then on this bar chart you can see that when the liquid rank reputation system is implemented, we can get much higher correct recommendations and pretty low percentage of the irrelevant recommendations. Also, another my student have implemented the prototype of the blockchain consensus mechanism based on that weighted liquid rank algorithm. So actually he has implemented reputation consensus for an arbitrary blockchain, and we have, and again the picture on this slide is showing how it works. So instead of relying on proof of work or proof of money, so which are assuming that forces either is that force is power or money is a power, we are considering that the reputation is a power, and using this weighted liquid rank algorithm where the importance or chance of the node to get the block formation right, where the value of the node is based on the pyramid or hierarchy of the reputation scores given by a person with account to the reputation of the participants of this hierarchy. This kind of way of weighting the node value is given more appropriate and more honest results. And here you can see that also the performance of the reputation consensus is good in such case. So when the amount of nodes of the network is growing, that throughput and average block time and consensus time are increasing linearly. So performance is of this consensus mechanism can be rather good. And also we have run the experiments, and it has shown that the performance appears pretty high compared to the conventional blockchain mechanism, especially if we fine-tune the proof of reputation consensus with the parameters that we have as part of its implementation. And also we can show that it is more resistant to different sorts of attacks that are known to blockchain consensus. We have considered few different computation options. Like you can, if you are implementing the blockchain consensus on a blockchain, you can compute what we call reputation snapshot, or distribution of reputation of every participants in the network, either on every block, or you can make it periodically. Like if that new block in the chain is being computed every few seconds or every minute or whatever, you can update the reputation snapshot more often, like once per day or once per hour. Also, different sorts of ratings, implicit or explicit ratings, can be involved into the reputation snapshot computation. Yeah, like you can use what we call transactional ratings, which can be explicit, like tips that you are supplying with your transaction for the person or a node computing some service for you, or you can assign some stars to the person or account or service that is being provided to you, or you can just make likes on a social network. So explicit ratings mean that you explicitly provide some bump or boost to the reputation of the account that you are rating. Or there might be implicit ratings. So for example, if a system is not designed to use reputation system, you can still get the data out of the system, like transactions, mentions on social media, or comments, positive or negative, that are given on the social media, and you can infer the reputation out of these ratings. Also there are things that we call endorsing ratings, like if someone follows someone, or puts some stake on someone, or just put some stars on the account, or not for particular service, we can have this long-term endorsing ratings also being part of the reputation computation, and then whatever is happening between the two snapshots is contributing to the new reputation snapshot being computed at the end of the reputation evaluation period. Also, we are considering different modes of the reputation consensus implementation for blockchain. Like it can be completely off-chain, right? So we don't have the reputation computation engine part of the blockchain. We have just some aside off-chain application which updates reputation snapshots. Or we may have some what we call reputation agency, multiple reputation agents computing the reputations for the same network, and then that's up to the participants of the network to select which reputation snapshot and which reputation agency maintaining this snapshot has more value and more reliable. Or we can make the reputation consensus algorithm considered as part of the blockchain. So the reputation might be computed as part of the blockchain protocol, and then reputation snapshots are part of the blockchain design, and then computing reputation becomes something what we call reputation mining. So the protocol should also involve some compensation or beneficial payments for the contributors to these reputation snapshot maintainers on the blockchain. And finally, it can be just sidechain. So you might have just another blockchain aside with the main blockchain, and this aside blockchain would be taking care about computation of reputation for the primary blockchain. So the reputation engine for the weighted liquid rank algorithm has the design described in the paper that is referenced here. I won't spend more time on designing the details on it. Just mention the work that is in progress right now. So we are trying to see how we can go further, and we are looking in how we can avoid more scamming or reputation gaming schemes within our reputation computation algorithm. Like one of the problems that is still not completely solved here is problem with reputation gaming. For example, you can see reputation gaming example here when there are nodes A and C are providing organic reputations to node B, and node C positive ratings to the node B, and node C is providing organic negative rating to node D, where node D is a scammer or reputation gamer, and the node D has its own swarm of the reputation gaming bots EFG, who are providing positive reputation to node D, and node D providing positive reputation ratings to the nodes in the swarm. So here we have what we call reputation circle, and using the algorithm that we are coming with, you can actually compute out these reputation circles, and then you can clean the reputation on the right. So on the left you have non-cleaned or abused reputation snapshot, and on the right you are getting what you have when the process of cleaning the reputation snapshot is performed. So the node B is getting organic positive reputation, and node D is getting organic negative reputation. You can also consider the same picture with the snapshot with the reputation score mapped to the range between 0 and 1. And again, in non-organic reputation gaming world, on the left you can see that node B and node D have closely high positive reputation, but after you apply the cleaning algorithm, you are getting node B having reputation at 1, and node D having reputation brought down to 0. So thank you for attention, and I am open to your questions.
Okay. Thank you very much, Anton, for your explanation. As we can see, it's a very important, I would say, paramount process and feature for centralized, decentralized, even though we are focusing mainly in one. But I do have a question from our chat here. If that's the same reputation system, the one that you presented now, that is being used in the SDAO.
Yeah, I think I honestly guess that parts of the reputation design is being used there. I'm part of the Singularity DAO, but in Singularity DAO I'm working more on social media analysis and simulation and backtesting on the market data. and I'm not working on the reputation system at the Singularity DAO per se, but definitely the ideas that I have been presenting are part of the reputation system, the design in Singularity DAO. Maybe Jan can get more information on extent to which it is true.
Yeah, please.
Oh,
You
yeah,
may.
so that was my cue.
Yeah.
Yeah, I can't answer that question. I don't know exactly how Singularity DAO is using their reputation system and how they are building it. I would expect indeed it has parts of Anton's agents. I do have another question, Anton, if I may. For deep funding, we are also trying right now to implement a very, very, very light and modest version of Reputation. But I'm a big fan of Reputation. For one of the reasons is that if you have a reputation system with a lot of sources and a lot of attributes related to it that you can measure, then you have a system that will enable you to equalize and balance different signals continuously. I have a number of questions about that. One question would be, do you see a system like that? Would it be possible? So suppose that we have been collecting data for 2 years, also thinking on Mindplex, for instance, and that system has evolved based on certain parameters that you score certain behavior. I'm not talking about people behaving and not necessarily systems or combination. And give certain points to certain behavior. Do you think it's possible in retrospect to say, for all this period of time that we are already collecting, we want to change the values of certain actions? Because then the system would have to recalculate everything.
Yes, that's question very good. So what we have been trying for that marketplace analysis, we have been trying to simulate historical data of the marketplace development, and we also were trying to compute the reputation over the time in a system based on the different, I would say, hyperparameters. And then we were able to see to which extent the hyperparameters for one run over the history or versus another run over the same history are ending up with more fair or less fair reputation snapshot in the end of the run. Okay, and technically you do can something like that. Start some community running from time from the beginning of the particular period with default settings of the reputation system, and in the end just get particular scores for every participant in the community. But then you can technically tell, okay, so now let's try what happens if we change the rules of the game, and you come up with different versions of the reputation states for after the 2 years, and then you may have some metric which would evaluate the fairness of the score. For example, in our experiments with the marketplaces, we were considering different financial metrics like amount of money that people are losing versus gaining, or correlation between the assessments for the accounts that are known as fake or known as alien, and accounts that are known to be fair and known to be good, and we were able to verify to which extent our scores are relevant to the ground truth verified scores. Okay, and then based on this metric we could say, okay, well, we have found that the default parameters that we were using over the time appears not right, so we would be changing rules of the game. And technically what we can do, we can say, well guys, we need to just recompute your scores. So you have such and such reputation, and you have such and such reputation. Now there are just two questions. First question is I would say policy, whether this kind of update of the reputation state in a community is part of the rules of the game. So the rule of the game may be that the rules of the game may change. Okay, that's number one. And second is just computational cost, because in order to do this exercise you need to spend some resources, and if it is a decentralized organization, that the decentralized organization should somehow decide that they can afford this computation cost. But the great question is great.
That actually brings me to another question, which is very much related, and I can already imagine the answer. I suppose that if you have a system without a reputation system, say Twitter, and you would be able to put parameters there, I can imagine that you could harvest reputation based on the same computational effort, and then going through the history, seeing all the links, and of course the computational effort becomes very hard with the liquid part, because that will require a lot of calculation, I suppose. But theoretically it would be possible to go to an existing system, and such a huge system would be extremely hard. A smaller system might be easier, and then retroactively implement a reputation system.
I was doing it for the Ethereum starting day zero. Eventually, unfortunately, I gave up with experiments, because it has requested too much computational power, which I didn't possess. But I was doing that for entire Ethereum, and with no issue, it can be done for any smaller system as long as you have the data, and you have the data in case of the blockchain.
So maybe we should give Elon a call and say that we can solve his problems.
Yeah, sure.
Another question I have related to this, Anton, if I may. Do we still have time, Rafael? I think so, right?
Yes, we do.
Okay. Andre Ernst, the previous speaker, talked about liquid democracy. So I think it's fantastic that we have liquid democracy and reputation, my two favorite governance mechanisms, in a row here. So I'd like to use this opportunity to ask you, how do you see the difference between them? One way of looking at it is saying that liquid democracy is just an other input of a bigger reputation system. But I can also imagine that there may be other ways that you can merge a reputation system with liquid democracy. What is your take on
I don't see difference, because the first paper that I wrote in 2017 and this was called reputation system as a liquid democracy. So to me, the weighted liquid rank reputation system is just instrument for implementing liquid democracy.
Yeah, trying to let that sink in, but yeah, I can imagine also that if you have if you have a reputation system, that indeed a liquid democracy is reputation. But it's reputation based on one attribute, being what other people think of you. And whereas the reputation system, that as I see it, might have many different inputs, might have an input, how much is this politician liked, but maybe might also have input, how often does he vote, and how often is he present in meetings, and I don't know what, talking about politics. So I can imagine that such a system would actually make a liquid democracy even stronger by saying getting votes from people is just one dimension, but there are other dimensions that will add to your popularity or reputation, which are not completely in control of the voters, but are otherwise determined.
Yes, so the design of what we call weighted liquid rank algorithm involves that there might be many ingredients. Like, for example, the reputation formula might blend multiple inputs, like how often you participate the voting process, how much money you contribute to charity, how many votes are given to you, and how money you are earning in a fair way, whatever. And then the parameters or hyperparameters of a system are just weights of this. And these weights, to be fair for the system, they should be the same for the whole community. It's part of the governance. It's part of the governance policy for a community. And as you mentioned in your first question, there might be a policy that the policy might be changed retrospectively based on some reconciliation process, which can be also aligned based on the votes of the entire community using the same reputation system.
Yeah, yeah. Fascinating. Yeah. So of course, those influencing those hyper parameters will give you, if you are able to influence them, then you have unlimited power. Because you can define everything. And I think some important character said, with great power comes great responsibility. But yeah, I suppose that would require in itself strong governance, I think. So going back to the way I see it with deep funding, which I will be talking about afterwards, we start with a relatively simple reputation system. The next stage could be to make it liquid, to make it more gradual. We are defining the parameters right now based on what we think is correct. At some point, and maybe we will change the parameters if we say something goes wrong, and then it might go this way, and then it might go that way, and then we change it again, and it goes this way because we are overreacting. And my expectation and my hope is that over time the system will get more balanced as it gets more signals, more inputs, and better managed hyper attributes, what it's called. And then when we are at that stage, then we should make sure that we have very good governance, so that any change to these hyperparameters would require a vote in itself by a proper committee or whatever. So yeah, just taking this opportunity because I think it's fantastic to hear your ideas on reputation and David Ernst's ideas on liquid democracy, and also know that we have a lot of ground to cover there before we are where we want to be. So thank you a lot.
Thank you.